Hello and welcome back. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be discussing yet another basic machine learning algorithm, and that is the K nearest neighbors algorithm, or it's commonly referred to as KNN. Now, KNN is another classification algorithm, and it uses existing data to come up with some metric of distance in order to map an unknown data point. So, without further ado, let's dive into how KNN does this and how we can use it in machine learning. Okay, let's go ahead and get started by discussing what the KNN algorithm is and how we can use it to solve a simple problem. So on the screen, you can see we have an example dataset, and in this case, it's a binary classification problem with two classes, the blue and the red class, and it's just a simple mapping of x values to y values. Now, for the most part, the blue values tend to be on the left-hand side of the chart, and the red values tend to be on the right hand side, so it should be fairly easy for KNN to predict some of the points. But we're going to look at the middle where we have some overlapping values and how those points can be predicted using the KNN algorithm. So throwing an example data point in there, this yellow one, we are going to go ahead and try to predict what class this belongs to using KNN. And first we'll discuss how KNN takes this data point and makes this determination. So KNN looks at neighboring values in order to figure out which class this belongs to. And the biggest parameter is the K value, and that is the K in K nearest neighbors. So this refers to the number of neighbors that we're going to compare that class to. And we want to figure out, based on our K value, which class this belongs in by looking at the K number of neighbors. So let's go ahead and try to predict this using different values for K. Taking the data point and starting with the simplest value, and that would be K equals 1. Now, as I mentioned before, it's just the number of neighbors, so it's just going to be looking at the single closest data point to the one that we're looking for. In this case, the nearest neighbor is in the blue class, so we will have one neighbor in blue and 0 in red. Now we take the majority as the predicted class, and in this case, that will make the predicted class the blue class for the data point that we're trying to predict. And let's go ahead and up that K value to see how it works for different values of K and when this prediction actually changes. So looking at K equals 3, you can see we are now looking at the 3 nearest neighbors, and 2 of those neighbors belong in the blue class and 1 belongs in the red. So again, taking the majority, the prediction will be the blue class. Now you may notice I skipped K equals 2. This was intentional. Typically in binary classification, you want to avoid even numbers because odd numbers will help you settle ties and you won't run into that problem. Now you can use even numbers for predicting, but you have to come up with some additional logic on what you want to do when there's a tie. A lot of the packages like sklearn, when you do this, they'll handle ties for you unless you want to define your own algorithm for it. But I tend to just avoid even numbers completely and only focus on the odd numbers. Okay, so that's out of the way. Let's look at some more values for k. We'll do a couple more examples. K equals 5. Now we're going to see that the 5 nearest neighbors is going to turn the tides of which class this is going to be predicted as. As you can see, we have 3 neighbors belonging to the red class and only 2 in the blue class. So now the predicted value will be the red class. Now, this is either good or bad depending on what problem you want. This may be what you want depending on what your data looks like, and the values of 1 and 3 were just too low for predicting your data. But it goes down to trying to find which value of k is best for your data and produces the best results. So while this changed the class, it may have been a good thing. You really just need to kind of use trial and error and run some different simulations to figure out which value of k is best for you. Now we'll go through one more example, k equals 7, just to show you, again, just expanding that circle around the data point to come up with these 7 nearest neighbors now. And once again, there are going to be 4 classes, 4 neighboring classes of the red, and there are only going to be 3 neighbors out of the blue class. So the prediction will once again be the red class. So overall, that's how the KNN algorithm works. Obviously, this is a very easy problem. It's only one value of x mapped to the output. And when you start looking at more features, you're going to be running into dimensions that we just can't even visualize. But this is essentially how the KNN algorithm will work even for 50 dimensions. It's going to come up with some distance metric in order to figure out how far away your current data point is to your existing data points for however many number of neighbors that you're trying to compare it to. And more advanced ways of using this, you can change how that distance is calculated. You can weigh closer points more than farther points, but for now, this is just a basic understanding of how KNN works. So I hope you guys got something out of this. If you did, definitely like the video. Subscribe to the channel if you want more content like this. I'm going to be using KNN in a few different examples. First one will be the IRIS dataset. So if you never used this before, check out that video series. And for now, that is all. I will sign off and thank you for joining me.